Hi friends, welcome to EPG Padasala. I am Dr. Karpagam Chinnamal from Chikana Government Arts and Science College, Tirupur. Today we are going to deal with the topic auxiliaries for dyeing. What are auxiliaries? Most of the operations in textile processing such as covering, bleaching are carried out by the use of basic chemicals like acid, alkalis, oxidizing and reducing agents, dyestuffs, etc. In addition to this, other chemicals are also used in relatively small quantities to increase the efficiency of the above said processes. These substances are called textile auxiliaries. Auxiliaries help by speeding up the processes or carry out the processes in a more efficient manner. Auxiliaries are important to obtain the desired effect. In this session, we would get to know about the different dyeing auxiliaries and also learn about the functions of dyeing auxiliaries. The basic functions of auxiliaries are to develop or improve the substrate for coloration, to transform the absorption properties of dyes, to stabilize the application medium, to protect or transform the substrate, and to improve the color fastness of dyeing. Let us deal with dyeing auxiliaries. Dyeing is the process of imparting color onto a substrate. This imparting of color is done by use of wet processing techniques. The chemicals added to dye bath that facilitate production of effective and quality dyeing are called dyeing auxiliaries. Dyeing auxiliaries provide high dyeing quality, process safety, and increased reproducibility on all kinds of substrates and machines with all classes of dye stuff. There are different dyeing auxiliaries. They are classified according to their functions and various uses. Some typical dyeing auxiliaries are sequestering agent, exhausting agent, carriers, leveling agent, dispersing agent, after washing agents, anti-foaming, dye fixing agents, migration inhibitors, and wetting agents. Let us deal with each one in detail. Sequestering agents or chelating agents. These compounds are used basically where hard water is used in dyeing process. The presence of metal salts such as iron, zinc, copper, manganese, tin, aluminum, etc. will affect the tone and brightness of color. A very small amount of sequestering agent present in the dye bath makes significant effect on dyeing. They react with metal salts in such a way that they become part of a complex ion. Commonly used softening agents are calgon, that is sodium hexametaphosphate, and ethylene diamine tetraacetic acid. Often it is abbreviated as EDTA. The formation of complexes is referred to as chelation and is manifested by what are called chelating compounds. The sequestering agents are helpful in reducing the effect of metal salts. Exhausting agents. Exhausting agents are important from the point of view of economical dyeing because they facilitate the movement of the dye molecules to the fiber and thereby exhaust the dye bath. Electrolytes like common salt or Glauber salt, that is sodium sulfate, is predominantly used as an exhausting agent in the dyeing of cellulose fiber with direct, azoic, vat, sulfur and reactive dyes. In all the above cases of dyes, the dyes act as anionic dyes. When a cellulose fiber is immersed in water, it acquires a negative electrical charge called zeta potential. As a result, the negatively charged fiber surface repels the negatively charged anions present in water. Addition of sodium chloride or sodium sulfate to the dye bath causes release of sodium ions which reduce or neutralize the negative charges of the fiber surface, as a result reducing the repulsion of the dye anion at the fiber surface. Hence, the approach of the dye anions towards the fiber surface is facilitated. In other words, the fiber takes up more dye in the presence of salt than in its absence. However, the extent of increase in exhaustion brought about by salts varies from dye to dye. With other dye fiber combinations, other chemicals are used as exhausting agents. The quantities of electrolyte present may vary up to 100 gram per liter depending on depth of shade required, dye structure, and recipe. Carriers. The crystalline nature of polyester fibers makes it difficult to obtain dark shades even at high temperature. To overcome this problem, carriers or accelerators are used to increase the rates of dyeing of polyester with dispersed dyes. It is also possible to dye at lower temperatures, that is 100 degrees centigrade, and obtain deep shades in the presence of carriers. Carriers are organic compounds, that is hydrocarbons, phenols, amino acids, amides, alcohols, esters, ketones, nitriles, etc. These dyeing assistants, when added to the dye bath, alter the dispersing properties of the dyes and the physical characteristics of the fiber so that more dye can be transferred from the dye bath to the fiber. There are a number of carriers commonly used for polyester fibers. Some of the good dye carriers are O-phenylphenol and its monochloro derivative, P-phenylphenol, diphenyl, monomethyl naphthalene, trichlorobenzene, dimethyl terephthalate, and methyl salicylate. Other dye carriers in common usage are O-dichlorobenzene, diphenyl ether, N-butyl phthalimide, chloromethyl crestonate, alkyl and aryl benzenate, and tetraline. Depending on the color and shade, the dye carrier used is in a variable range of 2 to 10% based on the textile weight. The use of carrier at 100 degrees centigrade increases the amount of dye absorbed and decreases staining on other fibers. Carrier normally have unpleasant odor that require the dye bath to be enclosed, and they may also be toxic. Let's look into the mechanism of carrier action. The carriers are found to assist the dispersed dyes to enter the polyester polymer, enabling dark shades to be produced. The carriers swell the polyester fibers and ultimately causes relaxation. They open up the internal fiber structure, that is, it increases interpolymer space and let the dye molecules to enter the polymer system easily and rapidly. Its action may be described as below. It creates dye film on fiber surface. Carrier takes dye inside the fiber from dye carrier association. It increases the solubility of the dye in the dye bath. Carriers penetrate inside the fiber polymer chain and thereby reduce interchain attraction. Thus, polymer chains become movable, and so dye molecules may enter the polymer system of fiber. It increases fiber swelling. The absorbed carrier increases the rate of dye uptake by creating liquid core fiber. It increases the absorbency power of fiber. It lubricates the thermally agitated fiber molecules. The advantages of carrier dyeing. In the presence of carriers, it is possible to obtain medium to dark shades on polyester. Materials can be dyed with simple equipments at atmospheric pressure and temperature below 100 degrees centigrade. Staining of wool while dyeing polyester wool blends can be reduced in the presence of carriers. Rate of dyeing is accelerated. Improves fastness properties of fabric except light fastness. The disadvantages of carrier dyeing. Carriers add to production cost of dyeing. Firstly, for dyeing, it is used, which is costly, and secondly, for its removal, alkali is required. Carriers are unhygienic and toxic. It creates skin diseases. Carriers affect the light fastness property of dyed material. This effect may be reduced by treating the material with hot air for 30 minutes. Some carriers are dye specific. They possess different efficiencies with different dyes. Others have compatibility with certain dyes. The factors normally considered for selecting a carrier are its efficiency, cost, effect on light fastness, odor, toxicity, discoloration of fiber, ease of removal after dyeing, stability during dyeing, compatibility with dyes, ease of dispersion, and even absorption by fiber. The next auxiliary we are going to see is leveling agents. While dyeing, the desirable end result is to achieve even or uniform dyeing. Many dyes have a tendency to rush on the fibers, causing uneven dyeing and shade variation. Leveling or retarding agents, when added to dye bath, ensure even dyeing by bringing about retardation in the movement of dye into the fiber. The degree of retardation varies from one dye to another. The quantity of leveling agents must not exceed 0.5 gram per liter of the dye liquor. Leveling agents are surface active agents and are chemically related to soaps, synthetic detergents, and wetting agents. Leveling agents are classified into two main groups, one based on ionization and another based on its structure. According to the ionic nature, they may be anionic, cationic, and non-ionic organic compounds. Anionic agent, the molecule of these compounds are negatively charged. Anions of the dye and anions of the leveling agents compete to get attached to the positive fiber site, thus avoiding direct absorption of anionic dyes to the fiber. As the bath is heated, the molecules develop sufficient energy to overcome the repulsive forces between the retarder and the dye, thereby leading to uniform dyeing. Cationic agents, the molecules of these compounds are positively charged. The cationic agents, when added to the dye bath, forms complex with the anionic dye and hence reduces the dye uptake by the fiber. The complex acts as a reservoir of dyes. When heated, the energy causes the complex to break down and gradually releases the dye and ensures a uniform absorption by the fiber. Application of leveling agents based on ion type. Anionic leveling agents are used on silk, wool, nylon, and bast fibers. Cationic are used on nylon and cellulosic, and non-ionic are used on synthetic and its blends. According to the chemical structure, the leveling agents are classified as fatty acids, that is ethylene urea, fatty alcohol, sulfated fatty amine, sulfated fatty alcohol ethylene. The two fundamental mechanisms that contribute to level dyeing are control of exhaustion of dye so that it is taken up evenly, migration of dye after initial unlevel absorption on the fiber. The leveling agents possesses affinity for the fiber, but this affinity is less than that of the dye, but they compete with the dye molecules to enter the fiber. So lesser amount of dye sites are available for the dye, limiting the uptake of the dye by the fiber. As the dyeing proceeds and temperature increases, dye molecules replace the leveling agents at dye sites. So uniform dyeing will result. They form large complexes with the dye molecules at low temperatures in the dye bath. The large size dyeing agent complex finds it difficult to enter the fiber structure. When the temperature of the dye bath is raised, the complex breaks up, releasing the retarding agent. The dye is now taken up by the fiber. Leveling agent first allows the dye to get into the fiber regardless of initial unevenness. During the course of further dyeing, levelness is achieved through migration. For this, selection of dyes for dyeing is of utmost importance, or it controls or retards the rate of dyeing throughout the dyeing cycle. Sometimes the leveling agent acts in both the ways. Limitation of leveling agents. The depth of shade is reduced by 10 to 15%. Therefore, in case of leveling agent, 10 to 15% more dye from the recipe has to be added. Next is dispersing agents. Dispersed dyes are insoluble in water and form aqueous dispersions in water. At first, these dye molecules are formed as large particles and they are made smaller particles by grinding. But as they are water insoluble, they will give uneven dyeing if they are directly used in dye bath. So to ensure uniform and trouble-free dyeing, the dye should be present in dye bath in an uniform and very fine form and should give a stable dispersion. This is the reason for which a special chemical is used in dye bath named dispersing agent. Dispersing agents are substances that promote more or less uniform and stable suspension of relatively small particles in a given matrix. The function of dispersing agent is to prevent agglomeration of individual dye particles during dyeing. Dispersing agents are much preferred for vat dyeing, disperse dyeing, and pigment padding. The anionic product ionizes water and form an electrical double layer. The mutual repulsion between these groups keep dye particles apart and prevent agglomeration. Dispersing agents are known to improve the migration and leveling of dispersed dye on polyester during high temperature dyeing. Dispersing agents should be effective under dyeing conditions stable to hard water, high temperature, and other dyeing assistants. Soap powder, turkey red oil, alkali sulfates, alkyl aryl sulfonates, sulfated fatty esters, etc. are some surface active agents which are recommended as dispersing agents in dispersed dyeing. Dispersing agents are described as sodium salts of any of the following: a naphthalene sulfonic acid condensation product, an aromatic sulfonic acid condensation product, highly condensed NS acid, disodium salt of methylene dinaphthalene disulfonic acid, etc. These are available in the form of yellowish brown powder, light beige colored powder, dark brown mobile liquid, and so on. The powder brand is a non-hygroscopic powder that is readily soluble in water with any degree of hardness. It's resistant to alkalis, acids, and salts and has dispersing and protective colloidal properties. It finds use in the dyeing of vat dyes by the vat acid process, also in dyeing with dispersed dyes, solubilized vat dyes, and azoic colors. In the dyeing of polyester and polyamide with dispersed dyes, the use of a dispersing agent leads to the production of a fine dispersion of the dye. Because of its non-foaming nature, it is recommended for the high temperature dyeing of piece goods or yarn under pressure. The functions of dispersing agent: it assists in the process of particle size reduction of dye. It enables the dye to be formed in powder form. It facilitates the reconversion of the powder into a dispersion which is required for dyeing. It maintains the dispersion in a fine form in the dye bath throughout the process. It increases the solubility of dispersed dyes in water. Other auxiliaries are after washing agents. After dyeing, most dyes are given after treatment with surfactants known as soaping. Along with soaps, there are a number of anionic, non-ionic, and neutral surfactants available for soaping or after treatment. Soaping causes aggregation of dye particles, which helps in developing true color of dye. In reactive dyeing, it removes unfixed dye from material, and in azoic dye, rubbing fastness is improved because soaping removes dye particles not coupled from the fabric surface. Anti-foaming agents: presence of surfactants in dye bath and continuous stirring lead to foaming. Formation of foam in the dye bath is undesirable and a problem to dyers as it leads to uneven or specky dyeing. Foam is suppressed by applying defoaming or deaerating agents. Anti-foaming agents are silicon based and are active at low concentration. To suppress the foam for million parts of dye liquor, 20 to 200 parts of agent is enough. Dye fixing agents: cotton dyed with direct dye have poor washing fastness and also color bleeds while soaping. To overcome this drawback, dye fixing agents are used. They develop a complex between the dye anion and cationic agents which improves the washing fastness. Migration inhibitors: in continuous dyeing methods, fabrics are dried after padding and before developing. This type of intermediate drying is carried out in hot air machine and they operate by evaporating water. Initially, surface water is removed as vapor and more water is drawn from interior of the fabric. Along with water, dyes also migrate to surface and would lack penetration, leading to uneven dyeing. To avoid uneven dyeing, migration inhibitors can be added to dye bath and carefully dried. Migration inhibitors for wet dyeing are common salt, sodium bisulfate, Glauber salt and sodium acetate. And for reactive dyeing, migration inhibitors are based on non-ionic polyelectrolyte and are superior to common salt or Glauber salt. Wetting agents. A small quantity of wetting agent in the dye bath facilitates the dye liquor to be absorbed uniformly and quickly. The dyes like VAT and azoic, which are not soluble in water, can be pasted with wetting agents such as sulfate oil or sulfated esters. Wetting agents are incorporated in the dye bath so that the fabric are uniformly wetted with dye solution. They also penetrate to the interior of the yarn. Wetting agents such as anionic and non-ionic agents of polyethylene glycol are used in polyester dyeing as the fibers are hydrophobic in nature. By using wetting agents, effective dyeing and excellent exhaustion can be achieved. Let us have a quick look at the auxiliaries used for various dyes. For direct dyes, salt is used to reduce negative charges on the fiber. Water is used as dyeing media. Fixing agent helps enhance wet fastness but usually reduces light fastness. In addition to the auxiliaries used for direct dyes, that is salt, water and fixing agents, soda ash is used in reactive dyeing to excite the dye to link with the fibers with covalent bonding. It enhances wet fastness. In wet dyes, salt, then sodium hydroxide. This is used to adjust pH of the dyeing bath and make suitable conditions for reducing agent. Sodium hydrosulfite is a reducing agent for the wet dyes. Water and oxidizing agents like hydrogen peroxide or acetic acid or air oxidizes the soluble dye to insoluble dye. In dispersed dye, dispersing agent makes the dye solution stable and disperse in the dye bath. Acid, it adjusts the pH to the suitable condition for the dye bath. Carrier swells the fiber and dissolves the dye to make the dye enter into the fiber. Leveling agent, make more leveling dyeing. Acid and basic dye. Leveling agent, as usual for levelness dyeing. And retarding agent for inhibiting the dye not to attach to the fibers too fast. The acid is used to adjust the dyeing condition and make the fibers to show positive charges in case of acid dyes and negative charges in case of basic dye. Apart from that, water is used as a dyeing media. So let's conclude this session. In this module, we got an insight into the dyeing auxiliaries and their role in dyeing. Textile auxiliaries play a vital role in the final outcome of a good quality dyed product. Hope you enjoyed the session. Bye for now and see you in the next module.